Hello guys, so today we are going to look at a very interesting topic in chemistry, extraction of copper. So, extraction of copper is very important in that copper is used in making cooking utensils, making wires. So, today we are going to look at extraction of copper. So, the extraction of copper basically involves three main stages. And before we talk about the stages, let's talk about the ore from which copper is extracted from. So, the main ore used to extract copper is what we call copper pyrite or chalcopyrite. Which has a chemical formula of copper iron sulfate. So the main ore used to extract copper is copper pyrite or chalcopyrite, and other ores that are used to extract copper is copper malachite, azurite, chalcocite, so the main ores are copper pyrite, malachite, azurite, chalcocite. But the main ore used to extract copper is copper pyrite. So the three stages used to extract copper are: 1. Concentration, 2. Roasting, 3. Electrolysis. So we are going to start with the process of concentration, the concentration of copper. So the process of concentration, we usually get copper pyrite or chalcopyrite, and then it is placed in a tank filled with oil. So when we place copper pyrite in a tank, a pressure is then introduced here, and when this pressure is introduced, the copper pyrite, it rises on the top, and then there is an impurity that we call dung that is left on the bottom. This impurity has no use. So when this copper pyrite is obtained on the top, this process is what we call flotation. So the main purpose of flotation is to concentrate the ore. To concentrate the ore, which is copper pyrite or chalcopyrite. So when this ore is concentrated on the top, it is then collected. So those impurities called dung are later removed. So another process of which the copper pyrite is extracted is roasting. So we get the main ore, and then it is then roasted in air or in oxygen. So when it reacts with oxygen, it forms what we call copper sulfate plus iron oxide and sulfur dioxide. So to get rid of this sulfur dioxide, it is then transported, or it is used in manufacturing of sulfuric acid. So this gas is very harmful in that it causes suffocation and it causes lung problems. And then we have another unwanted material in this reaction, which is iron oxide. So to get rid of this iron oxide, we usually react it with silicon dioxide or sand. So when we react it with silicon dioxide, we form iron silicate, which is slag. But the reaction isn't complete in that we are only removing impurities. So what we are left with is copper sulfate. Now if you look at copper sulfate, what we are interested in is copper. So when we react copper sulfide with another amount of oxygen, and remember this process is highly exothermic in that it releases heat. So when we react copper sulfide with oxygen, it forms copper and sulfur dioxide, which then adds to that sulfur dioxide that we produced to make sulfuric acid. So we have obtained our copper here, and this copper is not usually pure. It contains another impurities, in that we add sulfur, which is an impurity, iron oxide, which is an impurity, and we usually add down here when we were concentrating the ore, which is also an impurity. So during the process of roasting, copper isn't 100% pure. It contains impurities. So electrolysis. So electrolysis is the process that is used to purify copper. So during the process of electrolysis, we place a pure copper on the cathode side, and the impure copper, the one which you are purifying, on the anode side. So the main electrolyte that we use to extract copper, or to purify copper rather, is sulfuric acid, which is later added with copper sulfate. So this is the electrolyte. And if you remember very well in grade 9, you learned about an electrolyte, which is a liquid that conducts electricity, or the liquid that is used during the process of electrolysis. So on our anode we have our impure copper, and on our cathode we have the pure copper. We have the pure copper. So you now notice that ions on the copper will be moving from the impure copper going to the pure copper, because it is negative here. So the ion of copper, or the valence rather, it is positive 2. Now in that, copper is usually found on the middle of the periodic table, or it is in the transitional region of the periodic table. It has variable valences. So those variable valences simply means it can contain positive 3, it can contain again positive 2. So the most basic ion is positive 2. So the valences will be moving, or the ions will be moving from the impure copper going to the pure copper. So as it is moving from the impure copper, it is positive going to the negative, and you learn that negative and positive, there is an attraction. So the positive will be moving from the impure going to the pure, from the impure going to the impure, from the impure, going to the pure. So as it is moving from the impure, this impure releases what we call sludge, anode sludge, which contains impurities. So these impurities that are found on the anode sludge are basically mercury. These sludges are basically mercury and silver. That's what it was. So the impurities that are found under the anode sludge is mercury, gold, silver, and platinum. So you will find out that this impure copper will be a little bit small as compared to the one that we started with. And then you will find out again that this pure copper will be a little bit fat or big. So this copper, it now becomes 99% pure copper, which can be further be used as a substance that can be used to make copper wires, cooking utensils, and other things. So this whole process is the extraction of copper. This whole process is what we call the extraction of copper. So this process is very bulky and it requires a lot of understanding and revision.